My dear students, today we are going to discuss about the part 3 of your the basic nuclear physics, which we have designed it as your the nuclei part 3. As in your the nuclei part 1 and part 2, let us recollect your knowledge. In the nuclei part 1, we discussed what is the history behind your the nuclear physics, what are its the terminologies associated with it, the classification of your the nuclei as your the isotope, isobar, isotones and your the isomers with its the nuclear mirrors. Similarly, in the part 2, we discussed the intrinsic properties of the nucleus like your the shape, size, its stability and its density and its the volume. Today we are going to discuss about the next portions of your the nuclear physics, which we given the name as your the nuclei part 3. In that one we are going to discuss the nuclear forces, the nuclear stability, the mass defect, the packing fraction, binding energy and your the mass energy formula. All these are related with your the some problems we have to analyze today. So, my dear students, take your the copy and the pens and come forward and be given your the at least 52 minutes for the vivid discussion about your the topics which I provided before you. So, now we are going to find the what is your the nuclear forces. Nuclear forces. So, nuclear forces, it is a combination of the two words. One is your the from the term of the nucleus and the second one for its the force. So, inside the nucleus the force which to be exist, that is known as your the nuclear physics. Very easily you can say. Inside the nucleus, and we discussed what is the position of the nucleus, where you have been seated. If that one is considered as your the atom, means your room or the any area is considered as your the atom, just the head portion of your the needle, what area it will take, that will be treated as its the nucleus. Means if the this is your the atom, then this will be your the nucleus. And if that nucleus in your the nuclei part 2, we consider that it looks like your the sphere, but for your clearance I can say that, and we discussed it, it is not completely of your the spheres, and at the center it looks like your the sphere, and away from it, it is slightly your the aviated from that one. So, if this is the nucleus, means suppose this is your the very small part in its the extended form, and if this is your the nucleus, inside the nucleus what are remains? The protons and the neutrons. Means if this is the nucleus we have taken, that is the charge of your the Zd, and this is the electron, it may be in your the 1 orbit or the 2 orbit or the 3 orbits, you know, according to its the electronic configurations, that orbits are known as the K, L, M, N. And if this is the nucleus, it has your the protons and the neutrons. Let it has your the 2 protons and your the 2 neutrons. And if the 2 protons, 2 neutrons are there, then which type of the force will exhibit inside that one, that force is known as your the nuclear force. So, what type of the forces will be act here? Though this is the proton, neutron and neutron, between your the proton and the proton, they are your the charged particles, but for your the neutron and your the neutron, they are your the neutral particles, means there is no charge. So, between your the proton and the proton, there will be the force of the repulsion, because this is the positive charge, this is the positive charge, and between the two positive charges there will be your the repulsion, you know, in the electrostatic. So, if the repulsion will takes place between your the 2 protons, that 2 protons are inside your the nucleus. Never thought that only the 2 protons are inside the nucleus. There may be the 2 protons, 3 neutrons, or the 4 neutrons, or the 3 protons, according to its the configuration. So, if the 2 protons are there, then there will be the force of the repulsion. For the force of the repulsion, what will happen? Then they must be out from their position, means they to be repelled between themselves. So, between these 2 protons, this will be the force of repulsion, this will be the force of repulsion. Therefore, this proton will comes this side, this proton must be comes to this side due to the repulsion, but actually that is not happening. The neutrons and the protons are remaining inside the nucleus in a very small area or having your the very small volume, means these two repulsive forces, their effect is your the nullifying. Therefore, they are remaining that one. So, if the repulsive forces are nullifying, means there must be some another forces is there. So, these repulsive forces are your the electrostatic. So, this electrostatic force actually that is not happening there, because the protons are not coming out of the nucleus spontaneously. Next comes, between these two new protons, it has its the mass, that proton also has its the mass, and regarding the proton of the mass we discussed in our the previous class, and the mass of the proton is 1.67 into 10 to the power of minus 27 kg. Proton mass we have taken, mass of proton mp, and this can also be written in AMU, atomic mass unit, means 1.007 AMU, and this proton is also has its the mass. And if you will observe for this mass, between the two masses there must be a gravitational force. We know according to the Newton's law of the gravitation, in this universe every objects attract each other with a force. That force is directly proportional to the product of their masses and inversely proportional to the square of the distance. That we know in your the school level, also in the class 9th, and in the class 11th you also know. So, between these two protons there are also existing of the gravitational force. But you look, the mass of the proton, both are the proton, so the mass of the proton are very negligible one, 10 to the power minus 27. You just think of what the mass of that one. So, between these two masses, what the gravitational force, that is very negligible one. And for that negligible force, if some force greater to that one, a general force to be applied on it, they may be separated, but that separation is not actually happening for your the nucleus. For its the separation, we have to give in the more forces. Therefore, we can say that the gravitational force among proton and proton or neutron and neutron. Then you will say, sir, here the neutron and neutron not consider. Why the neutron and neutron consider here? Because this is the electrostatic force, means between the charged particles. These neutrons are here the neutral, no charge is there. So, the electrostatic force will not exhibit between them. And for the gravitational force, though it has its the mass, for the mass of the neutron, you know, mass of neutron 1.6749 into 10 to the power minus 27 kg or 1.008 AMU. We discussed. So, between your the proton mass and the neutron mass is slightly greater than that of your the proton mass, that is 1.007, this is 1.008, and here it is 1.6749, here it is 1.6724. So, this is a slightly greater, means it has its the mass. So, between these two mass there is also the gravitational force, but though that gravitational force is very negligible, so this gravitational force is also not taken into consideration. The third one is, though these are the charged particles inside the nucleus, they are in the motion, and when the charged particles are in the motion, they will produce the magnetic field, that you know. Magnetic field, when the charge will in motion or the current will flow, then that will produce the magnetic field, and due to that magnetic field, that charged particles will produce the magnetic dipole, will produce magnetic dipole due to the orbital motion or with its spin, or with its the spin, there will be the magnetic dipole. Due to the magnetic dipole, the dipole moment will be there, means that is one type of the force, but that force is also very, very negligible, and that is your the magnetic force is very, very negligible. So the magnetic force is there, that is negligible. Gravitational force is there, that is negligible. Electrostatic force, that is also the negligible. But we are observing that nucleons are bound together. So this shows that nucleons must associated with a strong force, and that strong force is known as nuclear force. That strong force is known as the nuclear force. So the nuclear force, it is much greater than that of the electromagnetic force. Hence, the nuclear force is that force with which the nucleons are remain together inside the nucleus, and that is the magnetic force. So in the magnetic force, that is the nuclear force. In the nuclear force, electrostatic, gravitational, magnetic force, these three forces has its the negligible effects. And if that is the nuclear force, then what are the characteristics of the nuclear force? Characteristics or properties. Characteristic or properties of the nuclear force. Number one, it is a short range force. It is a short range force, means within very small distance it is existing. Though the nucleus size, sir, why it is very short one? This is the nucleus we have taken. What is the size of the nucleus? You know the radius of the nucleus is 10 to the power of minus 14 meter to 10 to the power of minus 15 meter. You just think 10 to the power of minus 14 meter is very small one. So within that small range, that force is very strong. So it is the short range force. Number two is, it is not a central force. It is not a central force or tensor. It is not a central force. So central force means the force which to be exhibit between the two centers. So here the force which is existing not between the centers. So this force is known as the central force. Number three, it is a strong force. It is a strong force. So why we are saying the strong force? If to a nucleus, if slightly force to be given, then that nucleus will not be the separate among its the nucleons. Therefore, we will say that this is the strong force. Number fourth is the, it never satisfy inverse square law. It never satisfy inverse square law. Inverse square law means the force which to be exhibit, that will never proportional inversely to the square of the distance between them. As in the electrostatic force, the force proportional 1 by r square. For the magnetostatic, F proportional to 1 by r square. For the gravitation, the F is proportional to the 1 by r square. But here it is not 1 by r square. The fifth one is, it is independent of charge. It is the independent of the charge. And sixth one, it is dependent. It is dependent on spin. These two are the very important. It is independent of the charge. Whatever may be the charge, on that charge nature, the force is never related. Means between the proton, the force is there. Between the proton-neutron, the force will be there. Between neutron, the force will be there. Between neutron-proton, the force will be there. So the force will exist among the different particles. So it is the independent of the charge, and it is independent of charge. It depends upon its the spin. So these are the characteristics of the nuclear force. So inside the nucleus, the force which is existing, that is the nuclear force, and the characteristics of the nuclear force we have written at least the 6 characteristics. As we know, the nuclear force that to be the exist among the constituent particles of the nucleus, and due to the magnitude of that nuclear force, it will always try to maintain its the stability, or it will never to be remain in the stability position. So let us now discuss then what is the stability of that nucleus, and which is known as the nuclear stability or the stability belt. So stability, the word is taken from the parent word of the stable. So stable means, and at all the conditions it to be remain the same, that is known the stable. So that is the stability belt. Stability belt. So to find the stability belt, we have to draw a graphical form or the graphical representation between the neutron and the proton. Means every nucleus, it is the sum of the neutron and the proton. So the neutron and the proton are to be taken in the two different axes. So it observed that when this neutron and proton ratio is slightly equal to the 1, either equal or nearly equal to the 1, that is for Z less or equals to 20. Z means the atomic number, which is the proton number. The proton number is nearly equals to the 20. Suppose we will consider for the carbon. Carbon is the C612. So if it is C612, the neutron and the proton. Neutron will be the proton will be the 6. This is the proton, and the neutron will be the 6. So neutron by the proton is equals to the 1. Suppose you will go for the oxygen, O816. So neutron you will be the proton. Proton number will be the 8. This is the proton number. So 16 minus 8 will be the neutron. So the neutron number is the 8. Therefore neutron by proton is equals to 1. Here also neutron by proton is equals to the 1. And similarly, if we go up to the 20, 20 means the carbon. 20 means the calcium. For the calcium, that is the 2040. So 20 is the proton, and the 20 is the neutron. So if we draw a graphical form by taking the protons, so this is the 0, 10, 20, 30, 10, 20, 30, 40, 50, 60, 70, 80, and this is the 90. Similarly, under the y-axis, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is equals to the 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So, up to your the Z your the 20 means for your the 20. So, for the 20 you see the neutron and the proton here are the 1 ratio means from your the 10 to this 10, 20 to 20, this 30 to 30, this is 40 to 40 means from your the 0 to 20 their value will be the same means they will provide a straight line. So, if we join this straight line it will go likewise. But if you will go beyond your the 20 and within your the 20, suppose within your 20 you will take your the carbon C14. So, that is one type of isotopes. That is the carbon C14. Carbon C14 means it has your the neutron as your the 6, proton as your the 6 and the neutron as your the 8. So, neutron by proton ratio should be your the nearly equals to your the 1, but here neutron by proton is not your the equals to 1. So, this is the equals to 1 for the straight line. When it is not equals to 1 means it to be your the lie greater than to that one. And in some cases if that is not your the 1 that will your the lie below to this straight line. So, when it will remain below to the straight line they are not your the stable and above to that one they are not your the stable. Therefore, you look for the C614 and your the C612 it to be your the stable one means from here no disintegration to be happen easily, but this is not your the stable one and those who are not the stables they are generally represented with a star mark. This indicates that in your the C614 it may lose its the neutrons means it will happen to be your the C613 also, C615 also and C612 also. So, when it will come to your the C612 it will be the stable one, but beyond your the 20 this ratio n by p is not equals to your the 1 and for the second one when n by p is greater than your the 1 but it is less or equals to your the 1.6 they will not satisfy this straight line, because for the straight line they must increase in the uniform manner, but here they will not satisfy in the uniform manner and from here the stable one will be or the likewise and this straight line is not there. So, this straight line is not there means beyond your the 20 the elements which you have those to be remain on this curve they to be your the stable, but those who are not remain on this curve means your the darkened portion like your the dotted portions will be remain they are not your the stable and it may be greater than that one of the ratio and it may be your the less than that one of the ratio. So, on this line they will be called as your the nuclear stability belt. This is your the nuclear stability belt, but on your the below side what you are looking for this one n by p, for this one n by p. For this one n by p is below that belt means it is your the less value and it is above that one means it is your the more value. And if the elements which are remain on these regions they are not your the stable and they to be emit its the constituent particles either from this way or from that side, and on that way the disintegration of the rays to be the happens and that disintegration process is later is known as your the radioactivity. That radioactivity means it emits either alpha, beta or gamma. Just I said alpha, beta, gamma means it may emit your the alpha particle, beta particle, but the gamma is your the wave. If it is alpha particle to be the happen, the gamma ray is with it. The beta particle is there, the gamma is with it. Means the gamma is looks like a desert in your the fooding system. Means if you take here the veg, the desert is there. If you take the non-veg, the desert is there. And regarding this alpha, beta or gamma, we will go for your the next episode. So here it is the N by P. In both the cases, the nuclear fusion and the nuclear fissions are to be the happens. And such type of the characters which are satisfied by your the constituent elements, and they to be remain on this your the darkened line. That is not your the completely line, it may be looks like your the curve. That one is known as the nuclear stability belt. So after the nuclear stability, there is no question of your the disintegration, but those who are not in your the nuclear stability, the nuclear disintegrations will your the happens. Now we will discuss about another new term in your the nuclear physics, that is your the mass defect. This is your the mass defect. So defect is what? Means the thing which to be work in a specific way. If that will not your the happen, then we will say that that is in your the defective mode. Suppose you are saying that this fan is your the defective one, or our the vehicle or the car, that is your the defect, it has your the some defect. Means with it is the actual proportion of the working. If that will not happen in that way, that is called your the defect. Suppose you are taking your the calculator and you are taking your the some sums. Suppose 2 plus 3 will be your the 5, but the result it is providing as your the 6. Then we will say that this calculator is the defective one. So in your the nucleus, inside your the nucleus, the proton, neutron, neutrons are there. So that individual protons and individual neutrons, they have their the masses, and overall the nucleus has its the mass. But it observed that the mass of nucleus and the mass of sum of nucleons are not here the equal. Mass of the nucleus and the mass of sum of the nucleons are not same. Suppose we have the He, helium, means it is your the 2, 4. 2, 4 means by taking here the 4, it has its the mass. Overall the nucleus has its the mass, which we are generally taking as your the 4. Generally, because this is not your the 4, but in your my first class I said that your the mass of the proton and the neutrons we are approximately taken as your the 1, and mass of the proton is your the 1.007 and the mass of the neutron 1.008 AMU. AMU is represented by your the U. So this 1.007 that is taken as your the 7, 1.008 that is taken as your the 1. So that is 1.007 is 1, 1.008 is your the 1. Therefore, by taking your the 2 proton, 2 neutron, it is the 4. But the mass of the proton means 2 into 1.007, and for the neutron that is the 2 into 1.008. Because this is the proton, mass is your the 1.007 with your the 2 protons. So 1.007 into 2, 1.00 into 2, and that is equals to the 2.014. This is your the 2.016. So if you add them, then 4.03. So 4.03 of your the AMU. But we have written that is your the 4. So this is the mass of the nucleus and the mass of the nucleons. They are not your the same, and that difference is known as your the nuclear mass defect. Therefore, the mass defect del m is equals to your the mass of nucleons minus the mass of your the nucleus. This is your the del m. So, mass of the nucleons means your the z of your the mp plus a minus z of your the mn minus of your the mass of your the nucleus. So, this is called your the mass defect. Then the question comes, if the mass defect is there, then what that mass defect is making, or where that mass is your the going, and that mass is converted into your the energy as given by your the Einstein from its the mass energy equation that we will derive today. So, del m is equals to your the this much, means this del m portion is nothing but it is losing in the form of energy. Suppose I will say that this is your the nucleus and its the weight is your the x, and I just hand over on you, and by taking that x you taken what are its the different parts and you make the mass of the individual parts and they to be added, and you will find that that mass is not your the x, and that will be the slightly more than that of the x. So, that difference is your the del m, that is the mass defect. So, when it is transferred to you, it is losing or the gaining in the form of your the energy. So, by taking this concept, suppose I will give you one question, which body will have more mass? Number A body at a stationary, second one, the same body in motion, So, out of them which one will be the correct answer? A body is at a rest or the stationary and the same body is in the motion. Suppose this is your the way, this is your the body, and this body has its the mass, but this body now comes in your the motion. So, when it comes in motion, it has its the kinetic energy, and due to the rolling over here the road, it will produce the friction. Due to the friction, some heat energy will be developed. So, instead of its the mass, it will produce its the energies as in the form of the kinetic and in the form of your the heating effect. So, the mass is equals to the mass at rest plus some extra mass with it. So, why I said this is the extra mass with it? Because the mass at rest, the energy which it has, when it is in the motion with the same mass, it is going with its the motion. So, in that motion means that extra mass extra will have its the energy, and you know E is equals to your the del m c square. So, del m will be your the E by your the c square. So, this extra mass is due to your the kinetic energy plus of your the heating energy, and that kinetic energy, if that is equals to your the E, and that E will be your the del m c square. So, this kinetic energy will in terms of the mass, and that mass will be your the E by c square, means the kinetic energy by c square and the heating energy by your the c square. And the value of the c you know, that is equals to 3 into 10 to the power of 8 meter by your the second. And if it is 3 into 10 to the power of 8, means you will take its the square, means it is the 9 into 10 to the power of 16, and this 9 into 10 to the power of 16 when divided with its the kinetic energy, that value will be the very, very negligible one. Similarly, with the heating effect, that value will be the very, very negligible one. So, with its the original mass, some more masses which to be added, that is your the very, 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 very small. So, that is not generally necessarily taking into account, but for its the approximations value or its the clarity of its the result, we can say that the same body which is in the motion, it has its the more mass, and that difference in your the mass is your the mass defect. And we came to know that that mass defect will be converted into your the energy as your the Einstein. As you look for your the screen, it is observed that the difference between the mass of the nucleus and the sum of the constituent particles mass difference is your the mass defect, and that mass defect is converted into the energy by your the Einstein, and that energy will be in the form of your the nuclear binding energy, and that nuclear binding energy will be your the del m into your the c square. Then we will go for its the comparison, and before to going to your the comparison, we will find what is your the relation, how that relation of your the E is equals to del m c square being your the developed. So this is your the mass defect we discussed. Next we will go for its the binding energy. Binding energy, that is your the BE. So binding means to bound means to put together. So as you know that if you have your the exercise scripts or the books, the cover page is to be your the bounded, means you are saying that my book, that is a binding book one, your exercise script is your the binding one, means some extra more weightage are given to it for its the longevity. So here the binding energy means the energy which to be kept your the nucleons together, that is your the binding energy. Inside your the nucleus, the particles means the neutrons and the protons are there, that neutron and the protons with which force they to be together, that is known as the binding energy. And another example I will say that during your the CC roof, means the cement concrete roof, when it is your the going on, you are they are using the rods with the binding wires. You are saying that you have to taken the 2 kg or the 3 kg of the binding wires, means the rods which are there, that rods are to be bounded together, means that is your the binding one, means these nucleons due to some force, if they are taken together, then that is known as your the binding energy. Means the binding energy is the amount of energy which is supplied to keep the nucleons together, that is the binding energy. Suppose for the example, this is your neutron, this is the proton. These neutron and proton to be bounded means they to be kept themselves. So when they to be kept themselves with some force, they to be attached, and that minimum force through which they to be attached, that is known as the binding energy. On the reverse way I can say that, suppose the neutrons and the protons, they are bounded, and you applied some extra force from its the outside. So if from the outside the force will be given, if that force is just sufficient, the force with which these two neutrons and protons are bounded together, at that case they may be separate. So on the reverse way you can say that the amount of energy which is required externally to release the nucleons, that is also it's the binding energy. So taking these two factors, we will discuss in your the next ahead episodes, like your the nuclear fusion and your the fission. So that binding energy which to be required the nucleons to be taken together, that is your the E is equals to del m c square. Means here we can say that the energy and the mass, they are the equivalents. Del m is equals to your the E by c square, though the value of the c is very very small. So del m and the E, they are the equivalent, therefore that is also known as your the mass energy equivalence. Mass energy equivalent means mass and the energy, as I said earlier, that which one will have the more mass. The body which is in motion, it has the more energy. More energy means that energy can be equivalent with its the mass. So that therefore del M is equals to E by C square, that is the binding energy. So that del E means here the E will be here the del M. Del M will be here the ZMP plus A minus Z Mn minus M of your the nucleus. This is your the delta M into your the C square, and this is your the expression of your the binding energy. Binding energy will be the this much, and this much of the energy is always expressed in your the MEV. As I said earlier, for the energy level we have written the two stages. One is your the EV, one is your the MEV, one is your the GeV. The EV for its the atomic level, and MEV for your the nuclear level, and for the GeV as your the particle level. So BE will be your the this much, and for your the simplicity I will say that if the delta M is equals to your the 1 mu, suppose the mass defect is your the 1 mu, as I said, that mass defect can be equivalent with your the E. Sir, why you are not saying it is the E equal? But I am not saying the equality, the equivalence in that way, because it is the E by your the C square. This value of the C is your the very large. So E by C square means this large value if you divided, then that mass which is in the defect, only that person is converted to your the energy. Therefore we are saying that that is the equivalence, not it or the equal. So if del M is equal to 1 mu, if that to be converted into the energy, we derived in your the nuclei part 2, that binding energy is your the 931.5 of your the MEV. So this is the most important formula which is used to find the relation how the binding energy to be maintained from the mass defect. So as we know, the binding energy for your the 1 AMU will be your the 931.5 MeV. Then if the nucleus has your the more nucleons, then we will say that there will be your the more mass defect, and that more mass defect will give you the more binding energy. And if you will go for your the experimental evidences which we know, for your the heavy water, for your the heavy hydrogen, the energy which to be the required, that is the 1.1 of your the MeV. And for your the iron, that is equals to your the 495 of your the MeV. And for your the uranium of 235, the energy which to be your the binding energy will be your the 1800 of your the MeV. So for your the heavy hydrogen, sir, why you have taken for the heavy hydrogen? You see, for your the hydrogen 1H1. 1H1 means only one proton is there. So inside the nucleus only one proton. So what type of the binding energy to be required? Only one, means there is no others. So he is the almost all. So there is no bounding of that one. But when you have your the more than one, then there will be the some boundary or the some bounding. Therefore we have to take in from your the heavy hydrogen, means it is your the 2 means one proton and your the one neutron. So between them there will be the some energy to be your the bind themselves. Therefore we have started from your the heavy hydrogen and not for your the simple hydrogen. And if you will look for these three, so what can you say? Whose energy will be the more? Then you will say that For the uranium, though it is the 1800 of the MeV, it must be the more. So, if you are looking and if you will not go for its the internal matter, then you cannot say anything. Suppose there is a big house and near to that one there is a small house. So, on looking that big house, we will say that there the persons are living in the highway, in the spacious way, and in the smaller home they must be remain in the not in the spacious way, in the cloudy form. Is it true, my students? Suppose that is the big house and they have the 50 members and they have the 6 rooms, but it is the a very small house is there, only they have the 3 persons. Means the 3 persons are to be bounded in a room, but here it looks like the bigger one with the 6 rooms, but there are the 50 persons. So, the 6 rooms with the 50% means per a room there will be the nearly 8 persons are there, but that is the only one room, but the 3 persons are there. So, though we have not entered inside to that one, on looking from the outside, we are saying that this is the big house, means the peoples are remain in that house in the luxurious way, but that is not the purely correct, and it obtained that the iron will be the more stable one than that of the uranium. But though uranium has the 1800 MeV, no doubt, and the iron has the 495 nearly of the MeV, and looking for these two magnitudes, this is the more, but this is not the more stable. And to find that one, we will determine the binding energy per nucleons. So, if the binding energy per nucleons means if the per head, what amount of the exchequers to be the collected, according to that one we will say that that country is the richest one. Suppose we are coming interaction with the rich persons, then we can say that that state or that country is the more richer. Suppose the crores of the peoples are there, we only came in contact with the 5 persons, they are the crore prati. But what happens for the rest one? So, for that cases we are taking always per head. So, you have to go for the binding energy per nucleons, and it obtained that binding energy per nucleons means this is the binding energy per nucleons, that is in the MeV, and this is in the A, means the nucleons. Suppose this is the 0, 1, 2, 3, 4, 5, 6, 7, 8, and this is the 0, 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Likewise, you have taken. And it obtained that this is 1, 2, 3, 4, 5, 6, 7, 8. This is the 9, 8.8. From 1, it will go to 7. Then it will come down, then it will go, then it will come down, then it will go. This is the 8.8 MeV, and likewise. So, this is for the 1, this is the 1.1, this is for the hydrogen, this is for the helium, lithium, then boron, the lithium, carbon, oxygen likewise, and this 8.8 will correspond to 0, 10, 20, 30, 40, 50, and from 50 to this one 50, 60, 70 means from 50 to 60 means for the iron that is the 56. For the iron that is your the 56, that 56 will have your the maximum one, that is your the 8.8. From 50 to nearly of your the 80, that is your the maximum. But if this one we have taken for the uranium. So, for your the uranium that will your the 7.6 MeV. So, for the uranium the number of the nucleons which it has, the number of nucleons means proton plus neutron, that is your the 235. So, 1800 divided by your the 235 and here 495 divided by your the 56. So, 495 divided by your the 56, then what is its the value, and your the 1800 by your the 235, what is its the value, and this value is nearly of your the 8.8 and this value is nearly of your the 7.6. So, if this is the 7.6, it is the greater one or this is the greater one. So, this is the greater one and this greater one is your the binding energy, means the iron is your the more stable or the more stronger than that of your the any other higher ones. So, the three things we came to know, that is your the mass defect, one is your the binding energy and your the binding energy per nucleons, means that is your the A. By taking these three, we will now go to find your the sum of the problems and we will solve that one. Let us now come for your the first problem. So, the problem number 1, find the energy equivalent of 0.1 gram in your the kWh given C is equals to your the that much. Means energy equivalent, problem 1, energy equivalent of your the 0.1 gram. So, 0.1 gram means that is your the delta M, mass is your the given. So, you have to find the energy equivalent in kWh given C. C means your the velocity of light, that is equals to 3 into 10 to the power of 10 centimeter per second. So, these two things are here the provided. So, I know I said to you that if the problems are there, then there will the 5 steps. You know very well what are that 5 steps. The first step is the go through the question, second step is write is the data, these are its the data. The third step is the what is they are in the same unit or not. The fourth step is the either you have to find what is the relation between they are in the same unit, and the fifth one is the put the formula, get the answer. And here the two data are given, what is the asking, the third one is your the asking one is your the energy, and that energy you have to find out. So, if the energy is there, means this is the third step. Fourth step is the they are in the same unit. You see this is the gram, this is the centimeter per second, they are in the same unit. So, for the E you have to put E is equals to your the del M by your the E is equals to del M C square. So, del M value is equals to the 0.1 and C square value is equals to 3 into 10 to the power of 10, that square. So, this del M is in your the gram and this is your the centimeter square by your the second square. So, this is equals to 1 into 9 into 10 to the power of 20 gram centimeter square by second square is equals to your the org. So, this is the 0.1 of your the this one. But the question is in your the kWh. So, this org to be converted into your the joule. So, when the org to be converted to the joule means by your the 10 to the power of 7. When it becomes your the joule, then that to be your the kilowatt hour. 1 kilowatt hour is equals to 3.6 into 10 to the power of the 6, you know this much of your the joule. So, when joule came, you divided by the 3.6 into 10 to the power of 6 and that will lead to the final answer. Similarly, for your the second question, find the equivalence of the energy of this one. Means energy of this one means for the problem 2, energy is given and your the mass equivalence is asking, means your the del M is asking. So, you know the del M is equals to your the E by your the C square. The value of the E is given, C value you already know, so you divided that to 1, that will give you the del M. So likewise the problems you will find not only in your the syllabus of your the government of your the +2 or in your the CBSE, and you also find in your the higher entrances also. So please go through what I have given, that will help you, and you will go for your the next topic, which is your the radioactivity, for your the next episode. Thank you very much, my students.